Morning, Algebra 2 students. Glad to have you tuned in today, and excited that we've got just a little bit more this week, and then you'll be able to take a nice brain break, which you very, very much richly deserve since you've been checking in and doing all this, and I'm just really proud of you that you're putting in the effort. And so let's get to it today. Let's look at graphing radical functions. Okay, radicals having a root symbol in it, of course. You're going to find that it's pretty nice because it follows all the same rules of all the functions, and that's one good thing about this and with the math is that once you figure out basically how one of them works, they all pretty much work the same way. So it's very good. Like this, we just have a new parent function to be able to consider here. So it's the square root function. We're talking about principal square root only. We're not talking about the positive or negative thing, just the principal square root. If we were considering the negative, it would then not be a function anymore because each x would give you two different y values. So in order for it to be a function, we do need to talk about just the principal square root. So what that means is our domain in this has to be all the numbers first of all, that are greater than or equal to 0, because you know that you can't have a square root of a negative number. Let me say that again, because I know that there were a couple of you with the questions that you put in were saying that domain and range is challenging for you, and I get it. Your key thing when you're trying to figure out domain and range is you're really asking yourself what would make it not work. Because if you can answer the question, what makes it not work, it helps you to answer the question, what does make it work? Okay, so for example here, you look at this problem and you think, okay, if I had a square root of a negative, unless I go into the imaginary numbers, it really doesn't make sense to take a square root of a negative. So since the negatives don't work, that means that all the x values have to be positive. And in math, the way that we say positive is x is greater than or equal to 0. Now, as I said, I get it as far as it being difficult to wrap your head around that. But if you think about it as being the things that it can't be, it helps you to figure out what can be. And there's an infinite number of possibilities here of things that it can be. Okay, so you've got that. And that actually, if you can think about just the things, the positive things actually even in life, that helps if we can think about the things that we can have. But first we have to identify the things that we can't, if that makes any sense at all. Okay, so the domain here, the things that are allowed are the things that are positive in this case, greater than or equal to 0. So if you'll notice, I very carefully chose my x values. As you know, anytime you're making a set of ordered pairs and you want to get an idea of what the graph looks like, you can choose any numbers that you want to. But I strategically chose these because I was thinking ahead about the square root idea. Okay, I chose 0 because that's going to be the smallest. That's like at the edge of our domain. That's the smallest number that is going to actually make this work before you get to the place where it doesn't. So usually those borderline values are important just to get a handle on. So I'm choosing this 0 as my first one. The other numbers, what you might notice is I did choose perfect squares. And when you think about, well, why would she do that? Well, I chose perfect squares because I'm taking a square root. And the easier it is to deal with the numbers, the easier it's going to be to get a nice looking graph. So when we fill in these values, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2, and square root of 9 is 3. So very strategic on my choices for these numbers so that I get whole numbers that are easy to graph. So if you just take out a piece of graph paper or just do your best on a piece of notebook paper to make this work out, and we can make our basic graph here. What you kind of notice is it's a sideways parabola that doesn't have the other side, which kind of makes sense because remember, parabolas are based on squares, and so square roots, all it does is just turn it sideways and make it only positive in that. All right, so what I would suggest is that you pause it right now. If you don't have something that's going to work well for you as far as graph paper, if you're just using plain white printer paper, that may not be the best. You might want to actually find a way to print out some graph paper. There's a lot of searches that you can do and just print out some for yourself if you have the ability to do so, or at least make yourself the best sketch that you can. All right, so we have, this is our new parent function. So all of the other functions that we're going to look at today are shifts and stretches from this basic function. Some of them are easier to find. The ones that are up, down, left, right, and have nothing else going on but up, down, left, right are very, very easy to get from the parent function. So we're going to take a look. Here's our parent function. Here are our rules. Okay. Notice we're back to h and k again. This is, if this was really f of x, x minus h, and k, that would be helpful for that. This number right here is going to tell you if it stretches or compresses, just like exactly the same thing we did before. And it also tells us if it reflects around the x-axis before you get going on any of the other things. So there's a few ways to handle this when you have a stretch or a compression on here. But let's just start with some of the simpler ones. So there's going to be a few that we'll go through fairly quickly because this should be not too terribly difficult for you. So first one I want to take a look at is x minus 4. Remember, the one that's attached to the x, the h one, is the one where it almost feels backwards because it's x minus h. So that will give you a positive 4, which would mean the whole graph would move 4 to the right. And if you think about it, think about your ordered pairs for a second. Moving it 4 to the right means that the x value would be 4, and that will be where it gives you 0. So that should make sense. The whole thing is going to shift 4 to the right. So you start with these points and you count 4 to the right, and it's going to give you all of your new points. And your new graph looks like this, because the whole thing just slid 4 to the right. Same concept. We did the same thing with parabolas. We did the same thing early in the year with absolute value functions, the v-shaped functions. And this can extend to all your different functions that you might encounter ever. Once you have a nice baseline parent function, you can look at the other values to tell you which way it went from there. Okay, so the h tells you right or left. The k tells you up or down, so let's isolate one of those. Square root of x plus 3. Now, if you'll notice, the plus 3 is definitely not under the radical symbol. And I know that sometimes people get a little sloppy as far as where the radical symbol ends, and this is why I make a big deal about that, because if you extend this over, it means a whole different thing than when you've got the number completely detached from your square root. Okay, so here, plus 3, up or down? Well, in this case it's up because it's a positive 3. So the whole graph moves up 3. 1, 2, 3. A new dot. 1, 2, 3. So you would be counting 1, 2, 3, putting a dot here, and then the next one go to where the original was and then count 3 up from there. And another thing you can notice is that once you get started on these, especially if there's no stretch or compression, all you're doing is following the same pattern and just moving all the dots. So once you have your anchor point, you can very easily find the others. It's the same pattern. This is an up 1 over 1, up 1 over 3, up 1 over 5, and you can follow that pattern right along. And that works out just great. You can have combinations Okay. This one has an h and it has a k. Here our h, since it was x minus h, our h is -1 and our k is -2. So your basic point where you start the thing is at -1, -2. And then you can follow your pattern right along to make the rest of your graph, because really what you're doing, if you want to, you can even sketch in the parent function and think I'm going left 1 down 2, left 1 down 2, and then transfer it over to your new graph. So there's those, but they do follow the same pattern. There's a mistake here, so we want to fix that mistake. Do you see it? Okay, because it should be over here for that point right there. All right, there you go. That's a little bit better anyway. So up 1 over 5, up 1 over 5, but let's count it out also. Left 1 down 2. So this would be this ordered pair right here, which would be 1, 2, 3, 4, 5, 6, 7, 8, and up 1 would take us to here. So 1, 2, 3, 4, 5, 6, 7, 8, and up 1. So we've got this straightened out a little bit, even if it's not the most beautiful thing in the world. But we've got our key points in the right places, so that's important for you to be able to do. Knowing the pattern, knowing that everything is left 1 down 2. So we've got a chance to see that. All right, let's move on to another one where it's not just moving up, down, left, or right, but it's moving up, down, left, or right, and has a bit of a stretch to it, because these are trickier. And you need to go point by point, figuring out your stretch and compression, and then also figuring out what to do with the right, left, up, or down. So let's look at these point by point. This one's got a -2. So this tells us up right 3 and up 1, but this -2 is going to flip it over the x-axis, and it's going to stretch that number out by 2. So we're going to have a few things happening here, okay? And the calculations will come up in the next slide, but just so you see what's happening, since x is 0 here, I want to multiply by -2, which gives me 0, and then go right 3 and go up 1, so that my first point would be here. All right, the second one, this one, x is 1, so I want to multiply, y is 1, so I want to multiply that by -2, which would be -2. So I'm going down to -2, and then I'm going to go right 3, and I'm going to go up 1. Here my y value is 2. I want to multiply that by -2, which takes me down to -4. And then I want to go right 3, and I want to go up 1. This one, the y value is 3. Multiply it by -2 takes me down to -6. And then go right 3, and I go up 1. And my graph ends up looking like this. This is what I was just saying that I was doing, one thing at all, taking the y value, multiplying times this, and then moving it around. You can do that. The other thing you can do, which is maybe a little bit easier, is first just find your 0 anchor point. Okay, so right 3, up 1. Do that, and then instead of going through the whole multiplying and moving, it's even just as simple to say, okay, I'm going to plug in a 4 now. 4 minus 3 is 1. Square root of 1 is 1 times -2 is -2 plus 1, and get your points just by a chart, if that helps you. Okay, so once again, two ways. You can do this by shifting and stretching and flipping and then moving, or you can simply plug in values, x values, plug them in and get the y values that go with them. It's really especially when you include a stretch or a compression, it gets a little bit trickier to be able to follow. So here's our method where you're using the idea of stretch and compress and then moving. So first thing you do is affect the y value, then move it, or you're plugging in each x value, starting with the one that you get just by going right 3 up 1, then go 1 more over here, and then 3 more, and then 5 more, just to get your x values that are going to make it easy to work with. So not really the quickest way of handling these that have multiple things going on, but practice a bit with the assignment that you have. Most of the things you're going to encounter are going to have maybe 2 things to do or 1 thing to do, and not really deal with the stretches or the compressions very much. But I'm putting it out there because some of you are going to go way far in math, and when you get into the pre-calculus and the calculus and those type of things, you're going to need to work on this and have an idea of what's happening on the graph, so that you can move things around. And in trig we have graph shifts and compressions and all kinds of things going on. So this is just getting you started on that so you can see a couple ways of looking at that. All right, so that's that. I do encourage you this week, as we're getting ready to approach Easter, take the time to spend some time with God, get closer to Him, listen for His voice. It's a very interesting time that we're living in. Do all those things, work hard this week, and then be ready for a really, really good long rest coming up. So there's that, and I'll be praying for you. Have a very, very, very blessed day.